Okay, let's learn definition of 6 trigonometric functions based on triangle with the right angle. All right. Well, not precisely the same. Let me do a better job. Okay, much better. So this is our right angle, and this is our angle theta. So this is at the 90 degrees, this right angle. Here we have C, B, and A. So the side that is laying against the right angle is hypotenuse. So C is hypotenuse. All right. And the sides adjacent to right angle sides, which is A and B, are legs. Okay, so now let's identify trigonometric functions for the angle theta. So what do we have? I'm going to use red color, so we keep it here. Sine theta is the ratio of opposite side, which is opposite side for theta, it's going to be B, to hypotenuse, which is going to be C. Cosine theta is going to be adjacent side to theta, which is going to be A over C. Next, tangent theta, it's going to be opposite side, meaning leg, it's going to be B, to adjacent side, which is going to be A, B over A. So when you are dealing with tangent, you are dealing with two legs, while sine and cosine, you are dealing with one leg and hypotenuse. All right, so now let's go cosecant. Theta. Cosecant theta is 1 over sine theta, which means if you flip the ratio B over C for sine theta, you will get cosecant, which is going to be C over B, which means you take a ratio of hypotenuse to opposite side. Secant theta, to get secant theta, you take and flip the ratio for cosine theta, which is going to be hypotenuse to adjacent side. And cotangent theta, so take a guess. If you flip the ratio, that means you can insist that cosecant is 1 over sine, right? Secant is 1 over cosine, and cotangent is 1 over tangent. Because cotangent theta, also you flip the ratio, so it's going to be adjacent leg to opposite leg. Okay? All right. Now, based on this definition of trigonometric identities, let's solve couple of problems to find a specific value of be it angle or be it side for triangle with the right angle. All right? So, question number 1. We have triangle with the right angle. And we have here angle is 44 degrees. Okay. We have hypotenuse 8 inches and legs B and A. So let's find sine and cosine for our angle of 44 degrees. All right. So sine 44 degrees, it's going to be equal. We know sine of alpha, here it is, or theta in this case, is equal opposite side to hypotenuse, right? Opposite leg to hypotenuse. So opposite leg here is going to be A to hypotenuse, which is 8. So from here, A is going to be, this is symbol of hands, right? So since this is equation to bring to get rid of this fraction, what I'm going to do, this is what I'm going to do. Sine 44 degrees equal A over 8. If I take it as equation, so common denominator is 8, which means I divide here by 8, multiply by 8, right? Drop this denominator, and what am I getting? 8 times sine 44 degrees is equal A. Now, 44 degrees, since I need to get exact value of the side, right? Because I need to get size of A, right? Here. So I can move ahead until I know sine 44 degrees. I can not use here this trick unit circle table because I don't have here 44 degrees. That case is like, in cases like that, I'm going to use calculator. So iPhone, let's say mine is iPhone, in the calculator you punch 44 and then push the sign, and you should get 8 times. It should give you 0.694658. So if you multiply and round it up till the first decimal, you should get 5.6 inches. So A is equal 5.6 inches. Okay, now let's find B. There are two choices. You have hypotenuse is 8, right? You have hypotenuse is 8. Now you have A also. I can use Pythagorean Theorem and find out B, but it's not convenient for me because I have here decimal notation. And based on Pythagorean Theorem, okay, this is my triangle, this is my right angle. Based on Pythagorean Theorem, I can find B squared. It should be A squared plus B squared is equal my hypotenuse squared, which is 8 squared. And from here, B squared should be equal 8 squared minus A squared, and B will be equal 8 squared minus A squared. Since my A is 5.6, so it's gonna get messy, right? Or square it and subtract, and it will be difficult to get from square root. So what I'm going to do, This is one way actually. The other way, I'm going to get it through trig function. So I'm going to get cosine 44 degrees. Cosine 44 degrees, it's gonna be equal. Cosine is equal, here it is, adjacent leg to hypotenuse. And adjacent leg is, how much is it? B, right? In my case, is B over 8. Hypotenuse is 8. From here, using the same method, like this one, I used it, I can say that B 8 times, this is hence, 8 times cosine 44 degrees is equal B. Okay, how much is cosine 44? If you look at on your calculator, so B is going to be equal 8 times cosine 44 degrees, it should give you 0.7193398. Why did I take this long of a number? Because look what I have, 71933 and then 98. So it's these numbers can be rounded. They are more than 5. That's why I kept it. If it would be, let's say, 7190143, then I would get 0.71. That's it. But those are big numbers and I can round them. That's why I didn't round from the beginning. So this will be equal approximately 5.8 inches. So if you do this calculation here through B equal 8 squared minus A squared, plug A squared as a 5.6 squared, you should get approximately also 5.8 inches. Let me fix this equal sign. I don't put equal sign, I put tilde, which that means approximately. It's not precise. Okay. Next question, number 2. So this is, we found legs here based on trigonometric definition. So now let's find hypotenuse. Okay, based on trigonometric function. Hold on, let me do it one more time so I get in the good shape. There we go. So what do we have? Obviously this is triangle with the right angle. This is right angle. This is our angle, 65 degrees. Here this leg is 13 inches. And we need to find hypotenuse, C. So since I have adjacent leg, obviously then I can find out cosine, right? Because cosine is equal here, is equal adjacent leg over hypotenuse, correct? So I'm using cosine 65 is equal 13 over hypotenuse, which is C. From here, C is going to be equal 13 divided by cosine 65. If you want to know how did I get that, 13 over cosine 65, I'll show you. cosine 65 degrees is equal 13 over c. So bringing to common denominator, because that's equation, right? C here, c is here. So we drop c and c, and we get c times cosine 65 degrees equal 13. If I want to find c, right, what am I doing? I need to divide by cosine 65, right? Get rid of cosine 65 on both sides. I need to do same division. This is gone, and c is equal 13 over cosine 65. Okay? All right, back to our operation. So it's going to be equal here, 13. The value of cosine 65 is 0.422618, and that's approximately, it's going to be equal, tilde sign, it's approximation, 30.76 inches. Okay? Moving to next question. Now we need, let me see. Oh, okay, this is more interesting. Question number 3. We have, again, triangle with a right angle. So this is right angle, and this is our, let me see, angle beta, and this is our angle alpha, where alpha is equal, angle alpha is equal 40 degrees. So this is 40 degrees. Okay, and then this leg is equal to leg is equal to, if you're wondering what sign it is, this is a sign of angle. That means angle, guys. Make it nice. Okay. So what else do we have? Okay, we have this leg is A, another leg is 2, and hypotenuse is C. And so this time we are given one leg and angle. So we need to find angle beta, okay? And we need to find both sides, leg A and hypotenuse C. So something interesting about this case is we need to know that sum of all angles in the triangle is equal 180 degrees, which means I can write down angle alpha plus angle beta plus 90 degrees, right? Because we have right angle here, is equal 180 degrees. So it doesn't matter if triangle with the right angle or not. All sums are going to be 180 degrees. It just happened, we know it's a triangle with the right angle. That's why I put plus 90 degrees. It's equal 180. So if one angle is 90, that means how much it's gonna left on this alpha plus beta. Angle alpha plus angle beta also has to be 90 degrees, right? So total get 180. So if alpha is 40 degrees, then beta we can find out. It's going to be 50 degrees. Yes? 90 degrees minus 40 degrees. It's going to be 50 degrees. Okay. So let's find now. I can easily find leg A. Leg A I can find out using definition of tangent. So remember here what I said. Tangent we can find using two legs, right? Opposite leg divided by adjacent leg. So if I want to find tangent alpha, which means tangent 40 degrees, that's going to be equal. Opposite leg is A divided by adjacent leg is 2, right? So from here, A is going to be equal. A is equal twice, 2 times tangent 40 degrees. So A is equal 2 times tangent 40 degrees. You punch on calculator and approximately you should get, let me see, tangent 40 degrees, how much it is. 1 second. So you type 40 first and then you choose tangent, and I'm getting 0.839. 0.839. So now I need to multiply by 2 and the result is going to be approximately 1.68. Okay, so this is side A, leg A. Now now we need to find also hypotenuse C. So how I can find hypotenuse? I can go through angle beta. I can go through angle alpha. Okay. Let's go with beta this time. Okay. So I'm going to use cosine 50 degrees. Cosine of 50 degrees, that's a beta, right? It's going to be equal adjacent side A over hypotenuse C. Correct? So since A we know is equal cosine theta, cosine beta, which is 50 degrees, is equal 1.68 over C. Okay? So cosine 50 degrees, maybe we should use sine 50 degrees, so we would use 2 instead of 1.68. But okay, we started. You can use sine 50 degrees. So to avoid fraction, I already chose the hard way, so I'm going to finish it up. So cosine 50 degrees, let me see, 50. And cosine, it's going to be equal 0.65. Okay, 0.65 is equal 1.68 over C. So C from here, all right, if I bring to common denominator, it's going to be divide by C and multiply by C, right? This is gone, and I will get 0.65 C is equal 1.68. dividing by 0.65, dividing by 0.65, this is gone. C is equal 1 point, let me see, 1.68 divided by 0.65. And I'm getting 2.58, not precisely. It should be 2.61. Oops, what was that? Because of this. Okay, it should be approximately 2.61, but I got 2.58. You know why? Because I'm dealing with all rounding numbers. So absolutely it would be better choice if we would use sine 50 degrees, which would be equal for sine 50 degrees. This is our 50 degrees, right? So sine would be 2 divided by c. Okay, and you wouldn't have to deal with fractions, but that's okay. So instead of 2.61, I got 2.58. So, or unless you don't round it, you keep at least 4 digits, then you would get exactly 2.61. Round it up at the end. Okay. Moving to next one. Question number 4. So, we have triangle with a right angle. I need to pick this. Okay, what do we have? This is right angle. This is beta. This is alpha. We have this side A is equal 3. Here this side B is equal 2. And here we have C, hypotenuse. Okay. So we need to find angles alpha and beta. Okay. We need to find, we are given 2 legs. And based on 2 legs, we need to find angles alpha, beta, and hypotenuse. So for hypotenuse, we can use Pythagorean Theorem that says that square of hypotenuse is equal sum of squared of legs, which is equal b squared plus a squared. Yes? So from here, this is equal 3 squared plus 2 squared, and we get 13. So C is going to be equal square root of 13. Okay? So we have all 3 sides now, right? I can use any trigonometrical identity, sine, cosine, tangent, cotangent. Now, since my hypotenuse is square root 13, I'm going to avoid using this hypotenuse value, square root 13. Just like here I used, just like here I used decimal notation, and I lost the 0.02 decimal to be precise, close to precise. Therefore, I'm avoiding using a hypotenuse. So what do we have left to use? 2 legs. So which trigonometrical identity using 2 legs? Of course, it's a tangent. Let me clean this. It's a tangent and cotangent. Either tangent or cotangent using 2 legs, A and B. All right. Let's use it. So we have tangent alpha. It's going to be equal adjacent leg, which is free, over, opposite leg, which is free, over adjacent leg, which is 2. All right? Now, see, we have angle, and we can punch the number on alpha and find out easily. Yes? Now, how we're going to find out here? It's given result of angle. Now we need to find out, go backwards, which angle is matching, which tangent of what angle is matching 3 over 2. So to find it, we are going to write down as an inverse operation, which is alpha is going to be equal tangent to -1. -1, it's just the notation for inverse function, which means we need knowing how much the tangent of the angle is, and that is 3 over 2. We want to find the angle, which angle is matching 3 over 2. To do that, you are going to go now on my iPhone calculator. I don't have inverse function, but if you have the scientific calculator, or if you have calculator that has trigonometric functions, you should be able to find a trig function with -1 notation on the top. Okay, button. So you click 3 over 2 and then tangent -1, and that should give you alpha should be equal approximately 56.3 degrees. All right? Okay, so once we have alpha, guess what? Beta is going to be much easier to find out. So angle beta is equal 90 degrees minus 56.3. Why 90 degrees? Because this angle is already 90, right? So the other two sum, it's going to be 90. So to get 180 degrees as a total sum of triangle. Therefore, 90 minus 56.3 is going to be your result. That is going to be 7. 9 minus 6 is 3, and 8 minus 5 is 33.7 degrees. Okay, so this is the next problem. Okay, circle. Okay. And here another one. And circle. All right. So this is question number 5. Gee. So a point on the terminal side of an angle theta in standard position is 2 and -3. So 2 and -3. Where is the 2 and -3? That means this is 2 is our x, -3 is our y. So +2 is going to be this side, right? -3, it's a y, negative is going to be this side. So it's my angle is going to be on this side. Okay. Actually, a little bit going to be this way. because my x is positive 2 and y is negative 3. Okay? So this is going to be our right angle, right? Here also right angle. And what do we have? Our angle that is going to create the terminal side with standard position. It's going to be this one, let's say. Okay, this is going to be my theta, this angle. Okay, so, okay. Now, first of all, we have one leg is 2, another leg is negative 3. So we need also hypotenuse, right? So we can find sine, cosine. So to find the hypotenuse, it's which is our radius actually. This is hypotenuse, right? Hypotenuse, because it's laying against the triangle, against the right angle right here. This is our right angle. So see, let me make it thicker so you can see. This is our triangle that was created by this radius. Or this one, it doesn't matter. It creates two triangles with the right angle. Okay? So, first of all, we need to find the hypotenuse r. Hypotenuse r, because this is our radius r squared is equal to 2 squared plus negative 3 squared. Okay? And we have 4 plus 9 is equal 13. So hypotenuse r is going to be equal square root of 13. So to make it understandable here, let me draw separate. Gee, what is that? Okay, so this is our right angle, right? This is our theta. We need to use it to find all trig functions. This is our side 2. This is our y, negative 3, right? And this is our hypotenuse r. That's what we have. So r, we found out square root of 13. Now, let's go find out sine, cosine, tangent, cotangent, secant, cosecant. Okay? So, what do we have? If I go sine, cosine, okay. Sine is going to be let me see, sine theta is equal, so opposite leg, which is going to be negative 3, divided by hypotenuse, which is r, and square root 13. Let me write out here one more time. So we have sine theta is equal opposite leg over hypotenuse. Okay? Cosine theta is adjacent leg over hypotenuse. Okay? Tangent theta, opposite leg over adjacent leg. Remember, tangent working with two legs. Cotangent theta is adjacent leg, so we flip tangent, we get cotangent. Adjacent leg over opposite leg. Okay, And then from here, secant. Secant is going to be flipped cosecant, which is mean hypothesis. Hypothesis over adjacent leg. All right, and the cosecant is flipped sine, so it's going to be hypothesis over opposite leg. Okay, let's start working now since we have all information we need. I can make it much more comfortable. Let me see. This will be secant. This will be cosecant. I put against the function that we flipped. See, opposite sine is opposite leg to hypothesis. Cosecant, hypothesis over opposite. Same thing, cosecant. Secant is a flipped cosine and cotangent is flipped tangent. Okay, this is good enough. Let's start working. So sine theta is equal opposite leg, which is going to be -3 over square root 13, which is hypothesis. So since we can't have square root in denominator, we are going to rationalize, meaning -3 square root 13, and we multiply square root 13 here and divide square root 13, and the result sine theta is going to be -3 square root 13, and at the bottom we get clean 13. Okay, so next, cosine theta. Cosine theta, is equal, let me make it clean picture here. Cosine theta is equal adjacent. Adjacent leg to hypothesis. Adjacent leg is going to be 2 for theta. Hypothesis is going to be square root 13. And again, if I multiply and divide, right? Square root 13 here, square root 13 here, I will get 2 square root 13 over clean 13 without any square root. All right, next. Tangent theta is going to be equal, what do we have? Opposite leg, which is negative here, 3, to adjacent leg, which is 2. Accordingly, I can say cotangent theta is going to be how much? I'm going to flip and get, it's going to be -2 over 3, right? Okay, so next. Moving here. So why did I move? So I can put secant, cosecant. So if sine theta is equal -3 square root 13 over 13, then cosecant theta is going to be equal, if I flip, I'm going to get -13 over 3 square root 13. Okay, that means I need to do change, right, at the adjustment, because I have here at the bottom I have square root 13. All right, let me move this here. I try to put on next to it so it will be clear, but it's there is not enough space there. So therefore, that's not a big deal. I can make some here, sine here, and here. They are it's flipped fraction. So it's going to be equal. Now let me rationalize. It's going to be equal negative. So 13, here is 3 square root 13. Where is red color here? Times square root 13 times square root 13. And I'm going to get negative 13 square root 13 over 3 times 13, right? So this 13 is gone with this 13. And my answer is going to be negative square root 13 over 3, right? And lastly, secant, theta, it's going to be flipped cosecant, cosine here. So if I flip it, I'm going to have 13 over 2 square root of 13. Okay, we need to go through another rationalization. Square root 13, square root 13. And it's going to be 13 square root 13 over 2 times 13. This is gone. And I'm getting square root 13 over 2. And I'm done. I have enough for this problem. All right, moving. This is question number 5. Moving to next question. All right. Next question is going to be question number 6. That's right, question number 6. Here we will start working on coterminal angle. So what is coterminal angle? Coterminal, that two angles that share the same terminal side. Okay, let's say if this is my angle, these two are coterminal because they share the same terminal side, okay? That's what it is. Okay, so use coterminal angle to find the exact value of the following expression without calculator. Okay, we need to find out how much is sine 420 degrees. In the textbook, they put in parentheses 420 or 360, but I can tell you absolutely there is no need to put in parentheses the degree. Okay? So, how are we gonna figure this out? 420 degrees. So let me draw the circle. One, two, and now I'm drawing circle. Actually, I don't need circle. I know that this is 0 degrees, right? And then 360 degrees, right? This is 90 degrees, 180 degrees, but going by 90, 90, 90, right? Because each of them is 90 degrees, right angle, right? 180 plus 90, 270 degrees, and plus 90 is going to be 360 degrees. Okay, we have 420 degrees. We know that the cycle, one's full cycle is 360 degrees, correct? But we need 420. How much more we need to go? 420 minus 360, it's going to be 60 degrees, right? So I need to go another 60 degrees. I know right in the middle, this is going to be 45, right? So 60 is going to be a little bit higher. Okay. So it's going to go a little bit higher. Right here. And it will come here. So what does that mean? What can we say? That coterminal, it's going to be, sine 420 degrees, it's going to be equal to the same 60 degrees, right? Sine 60 degrees. Okay. Why? Because if I use this color from here to here, also the worst color I could possibly take. Okay, let me take this color. So from here to here, I also have 60 degrees. And I did full circle. I also ended up 420 degrees. I ended up on the terminal side of 60 degrees. All right, so now our task is making easy, 60 degrees. So we need to find how much is sine of 60 degrees. If I go to, where is this? Yeah, here. Let me bring this down. Let me see. I will drop it down so we can use it. I should have prepared earlier. I thought I will use it from the beginning. I apologize. Okay, but I brought it already, so it's not a big deal. And after that, I will keep pushing down, so it won't be difficult. All right, so we need sine 60 degrees. Okay, where is my 60 degrees? Here it is, 60 degrees. And so first one in parentheses, first come cosine, and then sine x. So we need to take the second one, right? Second coordinate for 60 degrees. Here it is, this is 60 degrees, and it's gonna be, sine gonna be square root 3 over 2. And which means here we are going to put equal square root 3 over 2. And we are done. Next one. Tangent 750 degrees. $750. So what do we have? Let's find out what is going to be coterminal for coterminal angle for 750 degrees. And then another one. Okay. So 750 degrees, how many 360 will fit in? Twice? because 360 degrees times 2. Why I take 360? Because it's a one full circle, right? 360 times 2, it's going to be 720. So yes, I will go 2 full circles, and then to get 750, I need to go another 30 degrees, right? Because 750 minus 720, it's going to be 30 degrees. So I'm going full 2 circles and plus 30 degrees. Let's start. 1, 360, 720, and 30 degrees. And coming here. This is 30 degrees. So tangent 750 degrees is equal tangent 30 degrees, right? So what is going to be a tangent 30 degrees? Tangent 30 degrees is equal sine 30 degrees over cosine 30 degrees. So let's find out 30 degrees. Where do we have 30 degrees here? Right here. So we have sine. Sine is 1/2. And cosine is square root 3 over 2. Okay, so tangent 30 degrees is equal 1/2 divided by square root 3 over 2. We get 1/2. We flip the second fraction, right? 2 and square root 3. So 2 and 2 gone. Now we are going to rationalize. We multiply square root of 3, divide square root of 3, and that's we get square root of 3 over 3. And that is going to be our answer. So tangent 750 degrees is equal square root 3 over 3. Okay? Moving to next one. Cosecant. 7 is 8. So cosecant negative 1050 degrees. Okay, with negative, that's why we need to put in parentheses. Okay. Negative 1050 degrees. All right, let's start working. So 1050, so since it's negative, then let me refresh your memory. This is our circle. So positive angle goes counterclockwise, right? This is positive angle, and negative angle goes clockwise. Right? Okay. So in this case, we are going to go clockwise because it's negative. So first of all, how many times we are going to go to get 1050? So 360 times 3, it's going to be 18,080, but we need 1050. So I will go three circles, full circles, and then back off, shorten by how much? 30 degrees, right? Because I will get 1080 instead of 1050. All right, let's go. And I'm going clockwise because it's negative, remember? So here it is, 360, 720. Now this is gonna be 1080, this position. But I need to go 1050, so I need to shorten by 30 degrees. It's gonna go, okay, like this. Yes? And which means it comes all the way to here. Correct? So this is 30 degrees. This is gonna be 60 degrees. Yes? All right. So what do we have then? Cosecant, negative 1050 degrees. It's going to be equal positive cosecant 30 degrees. Why positive? Because we go this way, right? Or negative 60 degrees I can put. Okay. So cosecant positive 30 degrees. All right, let's find out where was our cosecant, definition of cosecant. Here it is. Cosecant is flipped the sine, right? So, which is going to be, sine is going to be opposite to hypotenuse. But since we have flipped sine, I can go here in the table. So we need 30 degrees sine, right? And then flip it. How much is our 30 degrees sine? It's right here. Square root 3 over 2. Okay? Which means if sine 30 degrees is square root 3. No, I'm sorry. That's a cosine. I'm very sorry. That is cosine. 30 degrees is 1/2. First come cosine, second come sine. Okay. 1/2. Cosecant is 30 degrees is 1 over sine 30 degrees, right? Because we flip it, which is going to be equal 2. All right? That's how we get it done. Next, question number 9. Okay, cosine negative 35 pi over 6. Okay, let's see what will be coterminal angle for 35 pi over 6. 35 pi over 6 is equal 35 divided by 6, it's going to be 5 pi, right? 5 times 6 is 30, remainder is 5. So, and then plus 5 over 6 pi. Yes? Okay. So, when we have 5 over 6 pi, what does that mean? Let's say this is our pi, right? We have to divide by 6 pieces. 6 pieces, since every the quarter is 90, so divide by Each quadrant we divide by 3 pieces. 1, 2, 30 degrees each, right? 1, 2, 3, because 3 times 30, 90. Same way here, 3 times 30, 1, 2, 3. Each of them 30 degrees. So 6 pieces, and we divide by 6 pieces, and we take 5 pieces. So it's going to be 1, 2, 3, 4, 5, all the way to here. Yes? Okay. Let's work on it. So, graphing. Let's go 5 pi. It's going to be, and I'm going clockwise because it's negative. 1, 2, 3, 4, 5. And if I break down into 6 pieces, right, like I said, 1, 2, 3, 4, 1, so it will be 1, 2, 3, 4, 5, 6. So I will continue from here, coming all the way to here, right? It will come all the way through here. Off. All right? And this angle, it's going to be 30 degrees, yes? Because we broke down into 3 parts, 90 degrees, right? 30 degrees. So we can write down that cosine negative 35 pi over 6 is equal positive cosine 30 degrees is a pi over 6. Why? Because pi is 180 divided by 6, it's going to be 30 degrees, right? So it's going to be pi over 6 is equal pi over 6. Okay, cosine pi over 6, let's find it here. Let me move this on this side a little bit. Okay, pi over 6, it's a 30 degrees right here. So pi over 6, and cosine is going to be square root 3 over 2. All right, so we're writing down it's equal square root 3 over 2. I hope you understand the way I'm doing. I found this to be the simplest and best way because students having a lot of trouble to understand it. So this should help actually. Okay. Let me know if this is really good way to explain. If you understood, if you like it, this method, put like please, so I can know that you support this method. Okay, number 10. So I'll do 2 more and we will be done. Tangent. Now we're gonna do tangent. Negative 17 pi. Okay, tangent negative 17 pi. Okay, let's see how we're gonna work this out. 17 pi, quite a number. All right. There is nothing to divide here, so we are going to go 17 pi. So let's start. Because it's negative, I'm going to go just 17. So 1, 2, 3, 4, 5, 6, 7, 8. Just pay attention. Even number coming to the initial position, odd number 11 coming to 180 degrees is pi. Since I have 17, so I will end up here. So how many? 1, 2, 3, 4, 5, 6, 7, and so on. So I will go as many times as I have to, considering, okay, let's assume this is 17, okay? Because if you noticed, odd degree, odd amount of pi, I end up here. Even amount, if I go one more here, I will get even one, right? So this is going to be my terminal, considering there I counted 17. Let me write down. Okay, 17. So negative 17 pi, it's going to be equal tangent positive 1 pi, right? Here, if I come this way, same terminal, tangent positive 1 pi. Okay, so tangent pi is equal sine over cosine. Sine pi over cosine pi. Let me see, where is my sine pi? Here is my pi. My sine is negative 1. No, my sine is 0. Cosine is negative 1. So this is cosine and this is sine, right? Here, cosine come first, sine come second. So this is going to be equal 0 over 1 and equals 0. Therefore, tangent negative 17 pi is equal 0. Okay. And okay, next one, it's going to be the same thing, the same similar tangent. It's going to be negative 5 tangent, so I'm not going to do. This is plenty, so you understood, I hope. All right, so thank you very much for watching. If you like the way I explained, so please put the like so I will know, okay? Thank you very much. I appreciate it. And if there is any topic you would like me to cover it, let me know. I will gladly do so. Okie dokie. See you in the next video. Bye for now.